Welcome to Maths and Science Professor channel, and today we are looking at stems. We are looking at statistics. In statistics, we are looking at stem and leaf plots. Now, we have been given a set of variables, and we are told that these are the number of visitors to Railroad Museum in 24 randomly selected hours. And we have been asked to construct a stem and a leaf plot for the data that has been provided. Well, if you are to construct a stem and a leaf plot, you consider the first digit and the second digit of the variables that you have been provided with. Now, if we look at our set of data, the set of variables that we have, you consider the first digit and the second digit. For example, we have 67, 62, 38, 78, 34. Now, what we are supposed to do to make our work easier is to arrange this set of data from the smallest to the largest, although this is not compulsory, but then it will come handy in making our work easier. And let's arrange the set of data from the smallest to the largest. We have now arranged our set of variables from the smallest to the largest. We have the smallest set of variables 29 to the largest set, which is 73. We can now determine the stem and leaves of this different set of variables that we have. In plotting a leaf and stem, the stem and leaf plot, you consider the first and the second digit of each set of variable. The first digit becomes the stem and the second digit becomes the leaf. Now for example, you will have the first digit being the stem. We have 29. We will now have our table. We'll have a place for stem, and then we will have our leaves. This is how your table should look like. Now, we said that the first digit becomes the stem and the second digit becomes the leaf. For example, if we have 29, the first digit is 2 and the second digit is 9. We will have 2 as the stem. The second digit is 9. It becomes the leaf. We proceed to the next one. We have 29 as 2. Now the leaf will have 9 and 9. We proceed. We are done with the first two sets. We proceed to 30s. We will have 32. 3 becomes the stem. 2 becomes the leaf. We also have 34. 4 is the leaf. 35. 5 is the leaf. 36. 38. 38. We proceed to 40s. We have 4 as the stem. 1 is the leaf. 42, 43, 47, 47. We proceed to 50s. 5 is the stem. We have 51. We have 53. We have 55. We have 50. We proceed to the 60s, where 6 is the stem, and now 2 is our first leaf. 2, 2, 3. We have 3. We have 7 and 8. We now proceed to the 70s. 7 is the stem. We have 2 and we have 3. Now this is how you construct a stem and a leaf plot. Let's proceed to the second example and construct another stem and leaf plot. Now we said if you have a set of variables and you want to construct a stem and leaf plot, the easiest thing to do is to first have them arranged from the smallest to the biggest, and then it is not necessary, but then it will make your work much more easier. For example, we can go ahead and arrange our set of data from the smallest to the largest. And just as you have seen in the first example, when you do so, your work becomes much more easier. Now, having arranged your set of variables in ascending order, then your work becomes much more easier. Now, when you have variables in hundreds, then the first two digits becomes the stem, and the last digit becomes the plot, just as you are going to see. Now, we go ahead and construct our stem and leaf plot. We'll have our stem, and we will have our leaf. We have 102. We said if you have numbers in hundreds or variables in hundreds, the first two digits become the stem. For example, our first variable is 102. Now the first two digits is 1 and 0, that is 10. That's become our stem. We'll have 102. We have 108, 108. The next number is 113. 11 becomes our stem, and now we have 3. We don't have another 110, and so we proceed. We have 142. 14 becomes our stem, and 2 becomes our leaf. We have 144. We have 100, and we proceed to 176, where 17 becomes our stem, and then we have 6, our first leaf. We have 176 again. We also have 176. We proceed to 180. We have 18 as our stem. Then we have 184. We have 189. We proceed to 190s, where 19 is our stem. We have 2 as our leaf. We proceed to 209. 209, 20 is our stem. We have 9 as our first leaf. We have before 209 we have 205. 205 should be here, and then 209 we have 5 and 9. We now go to 210, where 21 is our stem, and 0 becomes the leaf. This is how you construct leaf and stem plots when you have variables in hundreds. Let's proceed and look at the third example. In our third example, we now look at something a little different, and now we are looking at back-to-back stem and leaf plots. Now, back-to-back stem and leaf plots is used when we want to compare variables in different locations or in different places. For example, we have here a set of data, a set of variables, and this set of variables are number of stories into a selected metropolis. We are having Atlanta and Philadelphia. Now, you can use back-to-back stem and leaf plot to compare these stories, these variables, the stories in Atlanta and Philadelphia. In constructing a back-to-back stem and leaf plot, it means you will have a stem that is shared by the leaves in both Atlanta and Philadelphia. And after constructing a back-to-back stem and leaf plot, you can now use the variables. You can use your construction to have a comparison, to make comparison and complement on the variability of data in the different places or in the different metropolis or in the different areas, whatever, two different places. That's where you use back-to-back stem and leaf plots. We'll go ahead and arrange our data in ascending order, both in Atlanta and Philadelphia, and then we will go ahead and then construct a back-to-back stem and leaf plot, as I'll show you. Now we have arranged our entries both in Atlanta and Philadelphia in ascending order. We have now made our work easier. We can now go ahead and make a stem and a leaf plot. In our case, the stem is shared by both the leaves in Philadelphia and Atlanta, just as we are going to see in our case. What you do, you have a stem. You will have your stem in the middle, like that. And then on either sides you will have leaves. This is let's say this other side is Philadelphia, and this other side can be Atlanta. We now look at our set of data. We start with 20s, the lowest entries. Now we'll have 2, and in Atlanta we have 26, we have 28, we have 29. Well, in Philadelphia we have 25. We proceed to 30s, where 3 is our stem. In Atlanta we have 30, we have 31, we have 32, 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 we have 34, we have 36, we have 38. In Philadelphia we have 30, 30, 30, 30, 32, 32, 33, 34, 36, 36, 36, 38, 38, 39, 39. We proceed to 40s, where 4 is our stem. In Atlanta we have 40, 40, 44, 44, 44, 47. While in Philadelphia we have 40, 40, 40, 40. We proceed to 50s, where 5 is our stem. In Atlanta we have 50, we have 52, we have 52, we have 53, we have 55. And in Philadelphia we have 50, we have 53, we have 54, we have 58. We now proceed to 60s, where 6 is our stem. We have 60 in Atlanta, 63. In Philadelphia we have 61. We now proceed to 70s, where 7 is our stem. And in Atlanta we have 70. In Philadelphia we don't have stories up to 70. Now, from this stem, back-to-back stem and leaf plot of metropolitan of stories in Atlanta and Philadelphia, we can make many conclusions from this. As you can see, the 70 stories are only found, it's only one, and is found in Atlanta, while there is no 70 story in Philadelphia. We can say 30 stories are major in Atlanta and Philadelphia, while there is a majority of them in Philadelphia. We can also say that the 40 stories in Philadelphia are much more similar, while in Atlanta they are progressive, as you can see, 40, 40, 44, 44, and 47, while in Philadelphia it is only 40, 40, 40. Now, from this back-to-back stem and leaf plot, you can actually draw many conclusions, and you can comment. You can make many comments based on this. Now, when you are asked to make a comment based on the distribution of these variables, you should be at peace in doing that.